Oh, hi there. We're glad you're watching one of our virtual lunch presentations. We have a lot of good information that we've been accumulating over the past several years, and we invite you to look down just below here and hit the subscribe button, and the little bell will give you a reminder of when our next presentation is published here on the YouTube channel. Thanks for your support. Appreciate it. Topics. We are open for topics. If there's something you'd like us to discuss, like today, the topic came along of AM single frequency networks, and so we'll address it. And I am really pleased that John Kean is back with us today. And John did a presentation for AES, which is what spiked my mind. And so, John, I'm going to turn it over to you to get started. Single frequency networks are not brand new.
No, as we'll find out today, they've been around a long time. I'm sure many of the guys on the Zoom meeting today know about that. And I see the turnout, and I'm really honored at the size of the group here. So thanks to you all for joining. I am going to do this in kind of an informal way. I've put this group of slides together very fast, and I hope you'll bear with me on that. Also, because of that, I'm counting on Barry joining me on this where he'd like to chime in and also participate in a Q&A afterward. Does that sound okay, Barry?
Absolutely. In fact, just a few minutes ago, I had a brief exchange with Al Kenyon, and he told me that before his career took a diversion, he had been working on a single frequency network for Cincinnati for one of the stations there. And so we go back in history, we can talk about more recent things, and certainly the measurements you've made, the charts you've got there, a lot of interesting stuff for us to talk about today.
Well, good. That sounds good to me. I trust my screen came up here.
Sure.
And so I'm going to go back with the Wayback Machine today, because this subject has actually been around for close to a century, if you can believe that. So that means digging up some old material here. See if we get this to advance. Here we go. So probably some of you know that this technology of ganging together AM transmitters has been around since almost the beginning of radio. And actually in the 1930s, it was really picking up speed, as noted in some of these clips from Broadcasting Magazine. That was back when Broadcasting Magazine actually had a technical section and reported on engineering goings-on as well as FCC filings. And if you browse through those issues, you'll actually see from time to time filings from stations saying they were authorized to build a second transmitter on frequency in their service area. Here's a couple of examples right here. And if you look over on the left bottom of the left side, you'll even notice that Western Electric developed synchronization equipment for those customers, which had to mean it was a fairly serious product. It's even mentioned on the other one to the middle. And the reason for this, is we still know today, is that AM radio is plagued with noise and interference, and that began with the start of AM radio. And there was always a desire to serve the market better, overcoming that noise and interference. Some stations, and we'll get into one kind of celebrated example next, knew that they couldn't serve their whole market adequately. with whatever power they were authorized. So booster stations or single frequency networks were looked at as one solution at that time. This is a clipping from the IRE proceedings, also from 1936, by a gentleman named Marriott. And he was just giving a rundown of the whole U.S. radio service at that time. And you'll notice in the green part here, he talks about chain broadcasting, part of which meant just simply networking stations together so they broadcast simultaneously. But in that second sentence in the shaded area, he actually does give a nod to chain broadcasting, where stations transmit on the same frequency. And he mentions that it's been in operation for about 5 years. Well, he was a little off by that, as we'll find out next. WBZ in Springfield, Massachusetts, was doing it for more like 10 years at the time he wrote this. In fact, to show that, we'll reach back to a copy of Radio Engineering magazine from 1931. This was, I think, the third time that WBZ wrote an article. I think the first one they did was in 1926. But this was quite a good article. Mr. Gregory got into quite a bit of detail on the subject, and you'll notice in the clip that I did from his article that he said the problem in connection with synchronizing their transmitter in Springfield, that was their main transmitter, and WBZA, which was in Boston, some distance away, was involved with the interference pattern between those two transmitters. And we'll touch on that a bit later. He said that results when two broadcasting stations operate on the same frequency. And so they were aware of that in the 1930s, that there was potential for an interference effect, you might say, between WBZ and WBZA. And he said in the case of their stations, the bad quality area, as he called it, resulted from synchronized operation and has been found to be quite limited. And at no place within the service area of the two stations has the reception been poorer than it was found to be with either station alone. So he was quite satisfied, and so were his colleagues, and I imagine his management, with the operation. And this network remained in operation until I think it was 1962, you said, Barry?
That's when WBZA was finally sold off.
Right.
The synchronized stopped a little earlier than that, though.
Okay. So it was on the air for many years. Gregory's article actually goes into some nice detail on how they did it. That block diagram in the upper left, it may be a little hard for you to read, but what you'll see is the main transmitter equipment in the left side. What they did is they divided down the fundamental frequency of WBZ until it was low enough to be transmitted over an equalized telephone line to the WBZA transmitter. They used that same equalized phone line to carry the audio for the program as well. So they were able to not only supply a carrier frequency reference, which was multiplied up again by those boxes on the right to 900 kilohertz, but also the modulation was carried synchronously as well, at least as well as they could do with equalized lines in those days. The article was kind of fun for me because they even included schematics of the stages, how they do it. So you can see the UX1 tube dividers they were using. and how they fed the telephone line and matrixed it with the audio and then sent it on to WBZA, where they unscrambled all that, fed it into the transmitter.
As we talked about the other day, let everybody else know, they didn't get that right the first time. It took them several years, and the local newspaper used to have a little piece in it saying how the reception was that day, whether it was good or bad. And it was about 1926, they finally struck the right technical setup so that they could carry this out.
That's right. Originally, they didn't do this frequency division and transmission to the synchronous WBZA transmitter. They used oscillators that they tried to keep as close as they could, although in those days, I don't think the oscillators were nearly as stable. And so I expect some of their self-interference wandered around the market a bit, depending upon how their oscillators were working that day. In fact, you'll notice in that clip in the lower left, he says, this was first put in operation in November 1924. And there's the call letters, which persisted for many years. They used power output at 250 watts initially. I thought this was a great illustration. It was a story on the same subject by John Schneider in Radio World in 2019, and I'll bet a number of you caught that article. And it's really kind of fun to look at because it illustrates an approach similar to what WBZ did. You'll notice that they have a transmitter A that's operating in that upper right corner with the master crystal control, sending the frequency information by telephone wires. It's combined with the studio audio apparently, and then rebroadcast in this transmitter on the lower left, the transmitter B. There was another approach, which I had an article on, I didn't include here. And the way one station system did it, and they said it was quite successful, they put a receiver midway between the A and B transmitters, and they sent the audio from that receiver, which picked up both transmitters, back to a control point. And they had a human operator actually listen to the audio, and he was able to adjust the carrier frequency on his local transmitter to tune out any beat note between the two crystals. That was a pretty good way to do it. I'm sure it worked well. A little bit expensive, but according to the article, it worked. Here's another article that was in the proceedings of the IRE in February 1931 by Eckersley, who many of you will recognize the name of. And he did a fairly thorough analysis, technical analysis of what happens when you have two stations operating synchronously. And you'll notice in his figure 2 diagram here, he has an example of the transmission of two stations. Interesting that service areas look so small because they really overlap in the case of WBZ. But in between, there's what he called the mush area. And that term, I think, still hangs around today. I've heard that recognized by some other engineers. He did a very thorough analysis. He even looked at things like in this figure 3, the range extension by operating two stations of equal power sharing the same wavelength, as they used to call it back then. Here's another article from a month earlier in the IRE proceedings by Charles Aiken of Bell Telephone Laboratories. This still remains one of the best mathematical analysis that I've come across for AM. He thoroughly evaluated the effect for both what he called straight line detectors, what we today call envelope detectors for AM, and square law detectors. And he evaluated the distortion that results from the signals operating at different ratios and different phase, RF phase. So it suggests to me there was quite a bit of serious study being done at that time. I seem to be getting a phone call there. Sorry about that. Here's one from 3 years later by Ken Norton. He was with the National Bureau of Standards, or the Bureau of Standards at that time, later joined the FCC. And so I'm sure a lot of you will recognize Ken Norton's name. He went out in the field and did studies on 2 AM stations that were operating synchronously, WJZ and WBAL in Baltimore. And you can see some of the strip chart recordings that he did. He's the one who did the strip chart recordings in the article that I used in order to finally find statistical information on the temporal fading effects of AM skywave. But anyway, he was out in 1934 doing these studies. So jumping way forward here to actually the 2000s, Stephen Smith in Tennessee, who's been active in the NRSC's AM Improvement Working Group, started working on an AM, synchronous AM solution. And by then, of course, we had the benefit of GPS satellites in orbit, and that constellation could provide us with a precise frequency reference. And what Stephen and his colleagues did was illustrate how that could be divided down, provide a reference signal, which could then be sent to modern AM transmitters, which relied on a usually on a standard frequency to which it then synthesized to put out on AM. So work was going on then, but long after a lot of the interest in AM single frequency networks, I think, had occurred. And as Barry indicated a moment ago, even WBZ discontinued their synchronous operation, I guess before that sale in 1962. Curious, isn't it? But I would say the reason is that there was limited technology to synchronize stations, and that resulted in frequency and or phase differences between the transmitters, which impacted the quality of the signal and caused that mush zone to move around. Much like what happened in my experience with FM boosters. There have been a number of FM boosters I've known of that were built with the greatest of expectation and then turned out to be a disappointment because it wasn't feasible to predict where the multipath interference would occur with FM broadcasting. And I was able to do studies at NPR Labs in the 2010-2012 timeframe with a large listener study to actually develop the coefficients for time of arrival and modulation phase, which could be put into a design model. That sort of thing really needed to be done for AM.
That was sort of an intermediary step, wasn't it, with Chicago and Omaha layout there, WBBM, KFAB. They had that huge, for the time, string of delay units to try to bring the audio together.
Yep. hmm And it is a very exacting science, and it can be done right. But as I say, unfortunately, some boosters uh, were lucky and turned out well, and others didn't turn out well, and no one really knew specifically why or if it was fixable. I think that may have happened in the case of the AMs. Plus, they started much earlier than FM SFNs and just didn't have the technology. They didn't have GPS disciplined oscillators in the 1930s and did the best they could. And sometimes that wasn't good enough. And I suspect that's the reason they disappeared over the 1930, 1940, 1950 timeframe. Here's an article, actually two of them that I kind of stacked up on here. Sorry about that. They're both by the same gentleman. As a matter of fact, does someone know who that is in the photo? I didn't put his name into my archive clipping. It was something that was posted in Inside Radio in 2017. And at any rate, this gentleman in the photo indicated that the Puerto Rico operation, which is also reported in the clipping underneath, where it was stated was in some peril. The FCC was giving the Puerto Rican single frequency network only a limited amount of time to continue their AM boosters, which is regrettable because that was a well-designed system. I have a copy of the design article on that, and they definitely knew what they were doing. They had the benefit of being a later system using a digital time delay for the audio, so they could offset and match the modulation phase of the transmitters as well as the carrier frequencies. At any event, the FCC became increasingly skeptical of SFNs in the 2010s. And in this article we're looking at here, it was kind of left to Commissioner Pai to try to take the lead and protect SFNs. Didn't seem to work out as far as I know.
I don't know if this is what, but his name was Wilfred Blanco Pai. Was down in the small print. Is that what you were reaching for? Second paragraph, first line.
Oh, that interesting. Kind of a coincidence. So that it looks like the station owner for that Puerto Rico operation, they had 3 transmitters on the island, the primary and 2 boosters at relatively high power, with good coverage of almost the entire island. So it looks like his name was Blanco Pai. The article here talks about Commissioner Pai, spelled P-A-I, and I actually had the opportunity to meet with him and show him a map, which I'll show here at the end. And he was quite impressed with that. Unfortunately, didn't seem to go anywhere. And as far as I know, the Media Bureau is still skeptical of AM boosters, which we'll have to talk about. Here's an article that in that same proceeding that Ron Rackley wrote as part of comments. And he said he was in support of the proposal to allow for permanent licensing of AM synchronous booster stations. I remember talking with Ron several years ago, and he and I were in agreement that it was eminently feasible if it was designed correctly. And so Ron made that filing. Here's the map that I think you all might find interesting. And this is the one I shared with Commissioner Pai. I picked a station, KMAS, out in Shelton, Washington, on the Olympic Peninsula. I'm a little biased there because Seattle is my hometown. And so I wanted to find an AM station somewhere that had communities in its outlying 2 millivolt contour area where it wasn't doing a good job of providing strong AM service. I was indicating here that to provide a strong enough signal for indoor service, I suggested 50 millivolts per meter was necessary. I'm afraid here at my house, where I have a bunch of wall warts, switching power supplies screaming away, that it takes about 30 millivolts per meter in my house to get a quiet AM signal. Although I did buy a whole bunch of ferrite cores, which I'm in the process of installing, hoping that will help quell some of the noise. But in any case, AM needs quite a strong signal to serve indoors these days. Yes, in vehicle, which is the predominant reception for AM, you can do it with quite a bit lower signal, maybe 2 millivolts. Kind of depends on the amount of RF environmental noise as well as interference.
Or if you're driving an electric car.
Yeah, at least those with poor suppression. I have a hybrid, a 2010 Mercury Mariner hybrid, and I've used it for some AM field study work for the NRSC's AM Improvement Working Group. They did a beautiful job suppressing noise on that 300 volt power system. I do not hear any noise from that. The only noise I hear actually comes from the AC alternator under the hood, and you have to put a strong filter on that. And get my kitty cat off the desk here. If you do use a strong filter on the 12 volt system in the car, it is a very quiet car electrically. But yep, I'm afraid there are some cars, as you said, Bill, that have a problem. So what I've done in this example here is show the 15 millivolt contour for KMAS. That's that shaded in area. And then it's 2 millivolt is the dotted line you see going out. But the towns of Olympia and Tumwater, Tanglewood, and Lacey are within the 2 millivolt contour, but don't really get very strong service. And I was posing that this would be a good example of where a single frequency network could reinforce KMAS's signal without extending beyond its existing 2 millivolt contour. So I assigned 2 100 watt boosters. You see 2 of them here in Olympia, one in Tanglewild, Lacey, and then the other one is a 50 watt in between in Tumwater. And it provides, I would say, contiguous coverage for KMAS, especially in these areas where its service does not reach indoors and is probably not very strong for many cars. So this increases, I think I did a pop count here. Yeah, the 15 millivolt per meter contour contained 42,757 people. If you included the pop count in these synchronous AM areas here shaded in blue, it brought it to 69,000 people. So it shows that a booster can really add to the population served by an AM station. The questions that we can kick around here are the economics of this, and I think I'll go to the last slide here. um, where I suggest that using modern technology that involves synchronous modulation over the internet between the primary transmitter and the boosters. That technology is available off the shelf. And GPS disciplined oscillators, it's quite possible to design AM single frequency networks. And fortunately, AM is quite a bit more tolerant of that mush zone than FM single frequency networks are. So, so that means that we have a much better shot at building AM SFNs. What we need, I would suggest, are these design parameters so we know how to go about designing a good system and being able to tell the manager, no, I'm sorry, but a booster is not going to work there for the following reasons, if that happens to be the case. So those design parameters need to be done. One thing that I am planning to do, Gary Cavell bought for me a used Hewlett-Packard single what's the word I'm looking for here? Well, it's a multipath generator. It allows you to bring in two carrier signals and offset them by a precise phase and amplitude. And that would allow me to carry out these measurements of what the mush zone parameters are, be able to put that into a table and offer that to you so you could use that in a design process. I think we also need to take a look at the population that would be served by a booster and along with the primary transmitter, and then do a economic analysis on it, sort of a business case study. If you needed to build out a whole network of SFNs, let's say you wanted to take down the big stick that was using a great deal of real estate, which could be worth millions of dollars in land value, that could potentially pay for a network of several lower power, lower height, single frequency network transmitters that could be distributed around the AM station's 2 millivolt per meter contour that's authorized. And I think that could cover the cost. So
John,
it would, yes.
John, this example from Washington, this was not built. This is something you proposed as a possibility, correct?
The laboratory measurements.
The three boosters there at Tumwater and
that one. Yeah, that was not built. That was just to pick a station as an example that I could show Commissioner Pai what you could do with an AM single frequency network, because at that time the commission was deliberating on this, and I had an ex parte meeting to show him these results. And he told me that when he was growing up, he fell in love with AM. He said his bedroom was on the second floor of his rural house, and he used to tune in at night to distant AM stations, and he loved being able to hear AM.
It's a shame that the FCC really did little more than bring FM translators to, quote, revitalize AM.
Yeah.
Let me question you just a little bit here. If you had built these little synchronous guys, Mike Shane wants to know, how tall a tower would you have used?
Well, I am not an antenna expert. Someone like Gary Cavell is. I would say, for efficiency, we would need to build, a quarter wave or taller tower. Well, you're back to big towers and big real estate again. Fortunately, since smaller antennas are less efficient, you need to put in more power to make up for the inefficiency. But generating power at AM frequencies these days is cheap and easy. So if you needed 500 watts instead of 100 watts to make up for a lower efficiency antenna, doesn't seem like that's much of a cost issue. There, I think probably some others here on the meeting may know of some low profile AM antennas they've heard of that might be candidates for.
Yes, Grady's ears are falling off right now. As we move forward through time in between the historical ones you mentioned and this, of course, we had this whole business with WSM and WLW and some others reducing the height of their tower because the Skywave was creating a blast right in their market. So this becomes something of a consideration. Then, of course, we have now the ability to really bring the carriers close together. And so KKOB's synchronous translator in Santa Fe, New Mexico, is maintained at 0.3 of a hertz off the main carrier, and they run that in the evenings and do a good coverage with that one. And then, as Kelly Alford brings out, we've come to the digital time where you get away from all that RFI with a MA3 digital AM station. What's your view on that? Should we maintain the analog, or should we just say you're going to have to go digital if you're going to improve AM?
Yeah, it's difficult to give a certain answer to that question. I would prefer to go to digital for AM for technical reasons because it has a much higher resistance to noise and interference, as you know, and that's been proven in Europe with Digital Radio Mondiale that provides great service. I remember when the CBC was running a DRM station on shortwave, that I took a portable radio out on my porch, pulled up the little whip antenna, which was like less than 2 feet long, and copied that station, which was in Newfoundland, from the Washington, D.C. area in the daytime in stereo with song title and artist and station ID information digitally, and a second multicast station going available as well. So shows the power of digital for this frequency band as well as for shortwave. However, look at the population of AM radios we have in cars right now. There isn't a practical way to make a hard switch to digital, in my view. That's a real challenge. It would be ideal, but difficult. You almost need to start on a new frequency band and go to a new generation of radios.
Well, we've seen a couple. We've seen WFED, and we've seen the one up in Massachusetts. If you started to proliferate and you had several transmitters, single frequency network, how resilient is MA3 to select the carrier or the signal you want?
I did testing on that with FM HD radio, and it works very well as a single frequency network. And I suspect that the MA3 mode for AM would work equally well. In other words, you could serve this big 2 millivolt per meter contour. Imagine you had other outlying communities out here in cities in the authorized coverage area. You could cover all of those in a synchronous network with MA3. So rather than having one big stick where your coverage begins falling off halfway through your market, you could serve the entire authorized market area. So I think it would work very well.
I'll raise the question, part of what we talked about the other day. Maybe someone who's with us today has the memory. Sometime in the mid 1980s or thereabouts, it was brought up as a plan for the New York City area to use what we might call today cell sites and take the 5 kilowatt highly directional stations and put a kilowatt around the city in those 6 or 8 places so that there was sufficient RF to cover the New York metro area without gaping loss of coverage. But of course, the big 50s didn't want any part of that. It never came to pass. But it was an interesting thought that you could take a 5 kilowatt with a severe pattern and put a kilowatt or 500 watts around the city and have enough to penetrate buildings or whatever you needed to do without having this problem. Anybody with us have any remembrance of this?
I do, actually. I was in New York at WOR when that was proposed, and all hell broke loose. As you say, the 50 didn't want to give up their dominance. And since I worked for one of them, I understood that. But it was not for AM. I think it was a single transmitter with DRM or some other digital form, and it would have equalized everything. And that was just not going to happen.
If you looked at the AM market and you said, well, we're going to do with the AM market what for more or less has been done in the cellular market, and say, well, so maybe everybody doesn't build their own transmitter site. Maybe an antenna tower company builds a tower and you load AM carriers on through a driver network. You load AM carriers on towers that are distributed up and down metro or well-populated areas. Then you could take some, all these like 50,000 watt, 20,000 watt, 10,000 watt stations that, in the case of the Shelton station, is spending a lot of time broadcasting to bears that don't own radios, really
with Washington, there'll be a plan very soon to make an outreach to provide radios for the bears.
Well, they've got that in spades. I mean, those bears they're the best covered people in Western Washington. But
Rich, excuse me for interrupting, because I don't want Rich to get away from us without telling us. Do you remember the date, and do you remember the stations that had purposed or proposed that single frequency network? Something we could look up and maybe find in the papers or magazines of the time.
I don't recall who proposed it. I just remember the fallout from it.
Yeah.
I think the proposed transmitter was going to be on the World Trade Center, and it was going to be digital. I wish I could think of could remember the dates, but I don't.
Well, if you do, let us know.
Okay.
Yeah, well, there's the problem, right, Rich? They also wanted to convert from analog to digital, and I imagine at the time that was too foreign to accept. And I wonder today if there is enough penetration of HD radio receivers to justify the switch to digital.
Kelly's just sent a note here: 22% car penetration.
Yeah, that's trading away a lot of one's audience to give up analog. And of course, if you've got a Class A or a large Class B AM station, you enjoy a huge coverage area. So, cutting off part of your audience would be a tough thing to do. But
Yeah.
for technical reasons, I certainly prefer digital. I just don't see that happening in the US. It seems like we need another kind of solution. For example, as kind of off topic, but I would rather see the Channel 6 TV spectrum allocated to AM only, and then gives you time for receivers to then include reception of that spectrum, and AM could start broadcasting. And then at some time in the future, you've got enough listeners to be able to finally turn off the AM band transmission.
It would make a lot of sense, but there seems to be an awful lot of money behind the Franken FMs and things like that. Before we move on to and again, maybe it's my fault here, but Bill, you were talking and I interrupted you to get back to Rich, but I got to give it back to you so you can finish your thought.
Okay, Barry. Yeah, I was just thinking. I mean, it's an ownership issue. If you could convince the owners that it would be in their best interest to sell off their directional antenna fields to shopping malls and pay tower companies to have their AM cellular, if you will, on tower sites, that might get past some of the geopolitical issues that you always run into. The other thing is that I remember at a time when I had a 45 RPM record player that ran through my radio, and you could build digital AM boxes like the digital TV boxes, I suppose, if you had a 57 Chevy that you wanted to keep the Delco radio in.
Here in the Washington, D.C. area, one of the stations on 630 kilohertz has been in operation for decades, and they sold off their land up near Gaithersburg, just outside the Washington Beltway, for tens of millions of dollars to build a housing development. I mean, it's a huge piece of land and very valuable. They moved that to share with another existing AM antenna. Gary Cavell worked on that project, and that was one way to avoid the need to find land elsewhere for a new tower, which would have again cost a huge amount. It's probably a compromise because it's probably not the most optimal location. And what I'm suggesting is a distributed network of transmitters using those tens of millions of dollars of revenue probably would be more optimal to serve the Washington, D.C. area than one big stick that's multiplexed.
I think one of the things that will get digital AM off the mark will be one or two of the major market 50 kilowatts going exclusively digital. Now I'm betting on WBZ and KFI. They're the two that have some decent ratings. Let's just see what they're willing to lose to do this.
See if they can take the lead. Yeah, that's a good thought. Right?
Who's going to be the sacrificial lamb to do that?
Well, they're in big markets with modern cars that have the HD radios that should pick it up, right?
I'm not a fan of HD radio, as many of you may know. I don't think there's enough penetration to warrant that.
But I mean,
Well,
they
we're
wouldn't
about
lose their
55.
audience because of lack of receivers. All the people in new cars, would be able to pick it up. So,
Yeah, we're at about 55 million plus receivers in the marketplace. Some of the portable radios are less power hungry and do a pretty good job. I've got a couple portables and all of my cars have HD. And, but we're not there yet. I mean, what's it going to take? 100 million radios out in the field? 200 million? I don't know.
Well, if you're, if you're someone like I have no heart, then you're not going to sacrifice, all those big mothers in those major markets. I sure wouldn't.
Right.
So what
Their
do you do?
business.
Buy everybody a radio?
Well, remember the days when you could get a fixed tune receiver? Just mail them out.
Well, you
And
know
it's
what? I mean,
working.
I do remember the government buying HD tuners for everybody when HDTV implemented. Remember
That
those
was
little tuners?
TV. They always get more money and stuff like that. I remember we used to sell little FM converters back in the early 70s that you could go to a car dealership and for $10, they bolted it under your dash and they plugged the antenna through it and then the output into your AM radio and you went to
Set
And
one of the
1620
buttons to
or,
1400 for you.
Well, don't forget that the TV move to digital didn't involve an individual company that was going to profit the way Ubiquity did with HD. So as I remember, the FCC was reluctant to give a single company all that power.
Right. Right.
Yeah, and digital television was introduced with free set-top converters
Yes.
to encourage people. And the change from analog TV with your 21-inch screen to digital with a flat screen was so remarkable. People didn't mind going out and buying sets. It's a little harder to make that comparison between analog and digital.
But didn't we start the notion of repack with the very first round of HD when everyone got their free converters? We had already taken the 50s and 60s out. Yeah, everyone got cards for 2 converters, and we were already looking at a more effective, more kind of defragged version of the spectrum with the top channels being carved out to go to other services.
And that gave the people the ability to watch when they changed until they decided to buy a new TV.
That we also had the 2-for-1. Everybody with an analog TV was paired temporarily with a digital one,
Right.
even if they were 80 miles apart. There were a lot of real interesting reception problems with co-channels that were not that far away, but you do the best you can. And then we crammed it down into the low 50s, and now we have it crammed, 36 and down.
Back in the 80s, I worked for Wometco in New York, and we did the Blonder Tongue digital pay TV thing, and that was we had 68 in West Orange, we had a translator on the North Tower of the World Trade Center, and then we had channel 67 on Long Island, and we actually did a stereo simulcast of Simon and Garfunkel in the Park using SMPTE time codes and broadcasting it through those 3 outlets. It was really a lot of fun and a lot of challenge, but that was that was digital. I mean, that was early digital Wometco.
And if you've got a big 50 kilowatt AM, like here in Dallas Fort Worth, we got KRLD and WBAP, and WBAP is a true clear channel, and they're making money, and people are listening to it, and it's mostly news talk type stuff. And so why take a chance if what you got without spending any more is making you money?
Because you have the 2 kilohertz IF in so many radios, which means that all you can do is talk or sports.
I don't think that matters to a listener. It's It's just not an important thing.
Yeah, I think that let's try that the other way, that if you suddenly sounded better, would that open an array of new formats to these stations? And I think the answer would be no, that yeah, great, WBAP now sounds better than it does with news and talk, but you're not going to put a new news format, I'm sorry, a new music format on it that someone hasn't thought of putting on 100 other signals already.
Right.
What we're going to need is something not just revolutionary. I mean, we're going to need, I think of the network executive in Scrooged, where he's telling Bill Murray, these scientists are saying that dogs and cats are beginning to watch television and we need to start programming for them. I'm not saying a new show, I'm saying some random pet appeal. And unless we start something absolutely different from what we've done before, it doesn't matter. I have a friend of a friend who will call up and say, you know, I have the Sequam cards for that transmitter you have, and I can have you AM stereo tonight. I will drive halfway across the country in 3 time zones to bring you those cards. And I'm like, that does not excite me as much as it does you. And you're like, oh, it'll be great. It'll be wonderful. Gosh, AM stereo is better than FM. If we didn't have the pre-emphasis, it would have been better. And I'm like, I'm going to reach to this phone and hurt you. At the very least, I am not going to let you come here and bring me the cards. Or if you bring them, I will break them with my bare hands. It's about the only thing I can break these days.
And maybe he lives in a terrible town and just wants an excuse to get out.
So the sales manager's always going to oppose taking the 50,000 watt off his business card and putting in 30 times 100 watt stations all over town. And until you can do all you want. So, but if you can't sell content, if you can't say, well, this is a better station than that is based on what it's transmitting, then you have to depend on the 50,000 watt on your business card to sell time.
And most of them, the 50 kilowatters, have switched over to the new energy efficient modulation schemes. And it's not costing an arm and a leg.
Yeah, so it's 31 kilowatts when you're not looking. But I mean, so I guarantee you, the second we have modulation, the power will come back. Yeah, the first time we ran MDCL, you look at it, you're trying to suppress the impulse to think of how broken it is. If you'd come in and your common point meter's doing this in opposition to the mod monitor, it's like, okay, they warned me this would happen, but gosh, that seems strange.
Why don't we go back? Oops, go ahead.
I want to go back to animal programming. My cat loves Animal Planet, so it might be worth it.
Put
Dog
little
TV.
mice. Oh, there's no picture. I forgot. We still don't have picture.
In that movie, they had Robert Mitchum, who just looked convincing as a crazed network executive.
Maybe quadraphonic would work on AM.
Yeah, well, I think what they need to do is go back to the real AM revitalization, and they need to take care of the ratchet rule, and they need to go back and roll this thing back, and they need to protect the 2 millivolt that I write a check for every year that to the FCC. They base my annual fee on the 2 millivolt that currently is unprotected. There's a lot of noise in the 2. So don't charge me for the 2, charge me for the 5. Let us push the 2 out. Since there's so much concrete and interference, give us a bigger 2 and then, protect it.
Or a noise deduction.
Huh?
Or a noise deduction.
Something, because this isn't a plan. They screwed us on revitalization. We looked at the software and it really made a difference for some of my AMs in terms of expanding the coverage area and covering area that the markets have, moved out to. And it was a real deal, and they got weak on it. They could have set aside the class, the clear channels. They could have set that aside and not touched them and opened up this revitalization for everybody else. It would have been glorious. And instead they got weak-kneed and went to translators. Totally screwed us. We had applications ready. It was beautiful. So, whatever. Keep paying that check every year.
Yeah, and translators don't do you any good in big spread out
Oh, heck
mileage
no.
cities.
Right. They're a Band-Aid.
Well, yeah, if you're in a town that's, plus or minus 10 miles across, it'll work fine. If you're one big city and there's a big tower in the middle of town, you'll probably do okay. But if you are
Dallas, Fort Worth.
Southern California, New York, if you're any place where, look, I need to cover a big chunk of plus or minus 50 miles, 75 miles. This is a big metro. I said, I can't do that 10 miles at a time.
Never going to happen.
And the
frankly,
bigger, the bigger
it's a
the
way
market.
of avoiding, it's a way of avoiding engineering rules and engineering standards and just throwing that all out and calling it AM revitalization.
Yeah.
well, no, you don't want to ignore standards, but there was a path forward that looked really doable and reasonable, considering, I think, that in practice today, because of concrete and this and that, and ground conductivities, et cetera, I think the practical is way below the theoretical in terms of coverage. And so give us a better 2 millivolt. I think people tune out primarily because they're sick of hearing traffic lights, blinking through their AM, or, which is not existent with FM. And they never talk about tropo with FM, but
Chuck Conrad reminds us of Eureka.
Actually, in New York, I think Eureka was the system that was proposed.
Well, Rich, like you said a little while ago, several years ago, I guess it's been 10 years or whatever, they were talking about maybe opening up a band for that. But nobody wanted it for exactly the same reasons that you mentioned just a few minutes ago. The big guys weren't interested in having the little guys sound just like them. Pretty
Right.
simple.
Yeah, they were looking at 220. And then, of course, we could have done it like Canada stuck it in L band. And we'd have had troubles with that because we were just discovering GPS. It's like, okay, no, we don't want anything near that.
Yeah.
Well,
Eureka was originally going to be the winner. Unfortunately, the NAB got behind Eureka in the 80s and in the 80s and 90s, and instead of supporting the technology, they tried to become the licensee of the technology.
They were going to be the dealer selling it. That's right.
They were going to profit from it, and
How corrupt is that?
I ran an SBE meeting at the New York Times auditorium where we invited all the group owners there. And I think Bill Paley even showed up and everybody else. And they just literally yelled and screamed at the NAB for going against the broadcaster.
They had a bus that year, remember? And they drove you around Las Vegas and parked under parking lots and said, now switch the switch.
And they did that at 400 or 500 meg. They stuck it on like channel 15 that was vacant in those days. But yeah, it was. And I remember the lockup time on the receiver was like 45 seconds. And the first time I see it, the guy opens one of the pans of circuits. And the first thing I do is I cycle the power. I want to see how long it boots up. And the guy's trying not to kill me and not to stop smiling. But he's like, for the love of God, don't ever do that again.
Do you remember?
Yeah, I remember you weren't allowed on a bus in Vegas for years.
You remember they got in trouble for simulating the AM study. The AM demonstration was simulated and they got in trouble for it. It wasn't real.
The biggest problem with AM digital is, and my good friend John Kean brought up the smart point that with TV, people saw the difference and they wanted it. The audience doesn't know about digital. They don't know to want it, so there is no demand for it. Okay, I mean, you're not gonna show. That's the same thing with HD radio. There is no demand for it, and therefore no one is getting educated to want it.
Well, you're right. It's incremental. It may be a big incremental, but it's like even in our stations, you put in a new exciter, you put in a new processor. When they first go to it, no one notices it. But after you listen to it 2 or 3 days, and then you flip back to the old one, I'm like, wow, that really is better. But you have to let your ears are connected to your brain, which lies to you constantly. And you're just whatever you're used to. Gee, it sounds good. It works good, works well. When you switch to the new audio again, like, oh, boy, this is clearer. This is cleaner. This is better. But like I say, it's incremental, and it's real hard to sell just plain folks on the street incremental.
Now, David, do you honestly believe that listeners wouldn't want Sean Hannity in digital?
Quad,
No comments right now.
quad.
I can't say anything at this time.
Well,
yeah,
you know,
it's you're right. The program, would the program sparkle better, or would it be, you know, harder to the left or right than it is today? You know, whatever you're listening to. What I used to tell people was, okay, if we do this, are our jokes going to be funnier? The anchor holding up Tuesday's Child, is this going to tug the heartstrings more? You
Well,
want to
with
adopt
stereo, you could have Democrats on one side and Republicans on the other.
All Delilah all the time.
Okay, if you're going to talk like that, I'm going to leave.
Nobody would listen to the station at all.
I would have loved to have the Mystery Theater in digital.
well, you know, we were originally talking about WBZ and WBZA. Now, I heard WBZA go off the air in the 60s. I grew up in the Springfield, Mass market. It was interesting that it was obvious something changed, but the quality of the signal didn't change. So I think the WBZA installation was, you know, with just a long wire between two towers on top of a building was really for Skywave. And at the time, once BZA disappeared, WBZ was still there, as strong as it ever was. Today, I'm still in that market, well, after leaving for a long time, but WBZ barely comes in, and I'm only 100 miles, and it's just all that noise. You know, a combination of noise and just lousy receivers. But I've got a great receiver in my truck. Still, the only thing I got on HD when BZ was running it were the call letters on screen. That's it.
It's a real shame that DRM did not take off for AM in the AM band in the United States. It probably would have solved everything. And that, or even Eureka, when it was originally proposed where it was going to be a cellular system. The problem was NAB was too greedy at the time.
Well, I'm willing to bet that Rick Buckley was at that meeting that you mentioned.
So
I
John,
know
you
Rick
were
was there because I chaired that meeting back then.
John, you were in NA or NPR labs or something when all that stuff was going on, all the standards selection, FM digital standard selection.
Mm-hmm.
What won the day for the current system?
Well, are you going back to the days when there was more than one DAB system competing, or after HD radio, the what now is called HD radio was selected? Are you going back to when there were multiple candidates?
In the before times.
Yeah. Well, that NPR wasn't too involved in those days. And that's a good study for somebody to do. Find out why the system we have today emerged. But I think it was the result of, wasn't it the result of a kind of a merger between two of the contenders? They figured neither one was going to succeed, and so they were stronger by joining together, and that created an alliance that formed the HD radio system. And at that point, it was sort of set in cement.
John,
Yeah.
John, I think you're pretty close. was it Zenith and Harris, I think, were the two that were working on it, on the systems, and they were very close to each other, and neither really had an edge over the other. And I think they were the two that merged, if I remember correctly.
Yeah,
Oh,
I can't.
and we had the other group that
Yeah.
was like Gannett and Westinghouse and a couple of the other broadcasters
Mhm.
had put a ton of money. And when Glenn Walden started making appearances, so it was always about the chipsets. And he would talk, I mean, there'd be papers on power diversity, on what you can do with various kinds of synchronous detection. Yeah, it was like everything. There's a lot of technology going around, and then it's okay, how do you roll this out? How will you implement this? I also remember about the time it was gelling as a technology, NPR may have been not cheering for it particularly, but it seems like the NPR stations recognize the multicast as their killer app, that wait a moment, we have second and third channels we could deliver, and a system that even if it gave us a lower third, fourth channel, this could be extremely useful. And I don't think commercial broadcasters saw that first. Commercial broadcasters saw, I don't want another channel on the air. We have too many now, and I don't want any more, which lasts until you watch your NPR station do it and said, well, that's kind of cool, and it doesn't sound that bad. Gee, I can put, the best of our front desk answering machine channel on my station is HD4. That'll be great.
Yeah,
And
you're
there
right,
was-
David. Yeah, NPR fought strongly for multicasting to be part of the HD radio standard.
And there were
I still have
PTFP
a,
grants. There were PTFP grants, and I could get a new transmitter if I upgraded to stereo.
Gentlemen, these are all interesting points, and there's been several of them that are really valid points that provoke thought. But I'm going to try to take a step to jerk us back sort of where we started. We've had a lot of discussion about single frequency switch networks for AM going full HD or a full digital on AM. We've even talked about bringing back or a resurgence of CQAM, but which I actually thought CQAM audio sounded pretty good when you were using a CQAM enabled receiver. Anyway, but one of the problems that we only kind of glossed on briefly was the noise and crap from power supplies, wall warts, LED lighting systems, whatever, that absolutely trash and nearly destroy using the AM broadcast band. Why hasn't the FCC taken a bigger step on enforcement of that, of eliminating the RFI from those devices? Every once in a while I hear something about that, but not much.
Show them a way to auction off the noise floor, and they will be fixing this.
If you had actual engineers working for the FCC instead of politicians and lawyers,
and economists and statisticians. I mean, when they stop listening to technical things in a technical service, it's like, hey, yeah, public interest this and public interest that. And it's like, okay, that's one set of criteria. But they started asking about, well, the economic impact on various groups. And I thought, okay, this is getting stranger by the second.
Well, I think we as engineers, so I guess that I punt that to like SBE and NAB, need to start making a major push, I guess, on the FCC and the government to do something about all the RFI and noise that's generated from power supplies, wall warts, and other systems that are just plain poorly designed. Oftentimes, when it would not cost all that much more to do it right.
It wouldn't, but wouldn't we need to find someone to ally ourselves with who are effective this? Because my mid-80s parents with their iPhones don't care. The phone does everything it needs to do. talking to them about how noisy the wall work isn't gonna be a very good conversation. You ask a 10-year-old the same question, it affects us because we're AM broadcasters, or just from a spectral efficiency thing, everything is signal to noise. You want more signal and you want less noise. And we shouldn't have let it go this way. We really, and when I was getting in the business in the late 70s, early 80s, I remember there was a lot of talk about RF lighting devices. People there, you know, said, hey, there's a new kind of light bulb, and the one thing it does is it kills AM radio in the whole room, or, you know, this end of the house.
Dimmers.
We could have, yeah, and dimmers. Yeah, it's like cheap dimmers. They're just nothing like it. We could have done more with that, but it didn't affect everybody, so we didn't do anything.
Well, at this stage of the game, how can you fix that?
Yeah,
I mean,
how do you?
there must be 500 wall warts in the building I'm in right now.
Yeah,
and I mean, we got. I think we're still running a couple CFLs, but mostly it's all LEDs. But there's computers all over the place. They're spewing out hash, and you can't get AM in here. It just, I mean, it just doesn't work.
Yep. Just like my house.
Well, it would take a few years. It would take years, but we
could do it, and we could do it, and it would take years. But what would drive it? What's the new? We want something to work. You know, it's like if you came in and said, okay, the world is maybe not going to end, but the EM pulse is going to destroy anything higher tech than your AM radio. That would, well, that would fix the problem. We wouldn't have to clean up anything. There'd be nothing left. But I don't know that there's a methodical way to do what you're describing, because what's the hook we hang it on?
Well, we're paying, they love money, and we're paying for a certain amount of interference-free protection from the FCC. We're paying so that other services like cellular and internet doesn't have to pay a fee to the FCC.
You're absolutely correct.
So we're paying a fee. So the next thing is, the next thing that happens is you file a lawsuit as a class action, and the judge says, courts of equity, the judge says, what are the damages? Well, my God, we'll show you damages. I'll bore you for a year on damages. But basically, it's going to take something like that. We are not getting what we have bargained for. That's a legal term. We're not getting it.
Yeah, the only way I see to fix it is to tell the FCC we're not going to pay their annual fees until they do something about the interference, and that's going to go over like a lead balloon.
Oh, sure.
And I'm sitting inside a station where the 13% rise took us over the de minimis threshold. Last year it would have been painful, but we'd have paid it. This year it's like, oh, great. For us, it didn't go up 13%. It went up an infinite number of percent, because like I said, we were excluded last year. And this year I'm like, oh, great. My fee is $1,020. Dear commission, I'm going to kill myself, and I'm sending the bloody gauze to you.
No, I wish you'd pay my bill. It's going to be about $7,000, I think.
You bought more stations than I did, Chuck.
I know, but somebody said if you have that many stations, it's inconsequential. Well, that's bullshit, because it's very consequential.
I consider it very consequential. Yeah.
27,000.
Well, and still working backwards, that's just a question of how big is the check. But you're absolutely right that there are these other services that, okay, you don't get itemized when the commission says, here are the costs, and I need to make them equal this number of applications and things, papers we've shuffled. They didn't count everybody. And I'm like, okay, why am I counted? Because we're more visible or we're more old school? They know about us.
Yeah.
That's life in business anyway. You can start out, everything's great for a long time, and all of a sudden, all the various agencies that seem to oversee whatever their purview is, start finding you, and all of a sudden you've got a whole bunch more paperwork and fees to pay and all kinds of stuff that you didn't have when you first started in business. But once you became visible, here it comes, and it doesn't matter what you're doing.
I had a professor of history who would talk about that. He said the early big West Texas ranches were just vast pieces of land and just free range animals everywhere. Just corralling them was a big deal. But those guys did not want fences. And it's like we had songs, "Don't Fence Me In." It's like, okay, you make it ethical and honest, you'll squeeze some people out of business. Now people figured out how to make it work, and it continued. But yeah, everything you do, you go along for a while and it's, maybe this is not how it should have been, but this is how it evolved. This is how it got to us and we liked it. And then suddenly it's, well, we're going to have to coexist with someone else who may have a different opinion.
We're kind of at the stage at this point, I think, that it's like you order milk in a restaurant and they bring you chocolate milk and you say, take it back and get the chocolate out of there. I mean, this is, you know, take it back and get the plug, you know, the wall warts and the Philips LED lights that blank out FM stations. You know, the chocolate's never coming out, and I think it's like, what technically do you do to overwhelm the noise or work within it? And how do you get the FCC to agree and the owners to agree that that's a good thing in the end? You know, we've kind of gotten past the whole idea of in the public interest. I think we don't do that anymore that I can see. So, you know, do we get back to that? Do we say the AM band is worth saving and we're saving for this reason, and build a system that works within that solves that problem?
I think one thing that might help would be to get the FCC to have some stringent rules on receivers, because a lot of times the problem is the receiver itself. It's a piece of crap. I have a 1985 car that has a GM AM stereo radio in the thing. Now, I do not broadcast an AM stereo, but when you push the AM stereo button on the thing, all of a sudden it opens up the IF frequencies on the thing, and it sounds wonderful. It sounds almost as good as AM. It's not stereo, but frankly, I don't think most of the general public would know stereo if it jumped up and bit them in the rear end or something.
Yeah.
You know, occasionally you hear something that's stereo, but really good mono that sounds really nice. And you can do that on AM without doing anything strange. I mean, I'm just talking 1,000-watt non-directional stations here that are, they're well processed, but it actually sounds good in this car.
Is there any company here in the US that makes radios, receivers?
I doubt it.
Is there any company that sells AM radios?
Well, that's another good question, isn't it, Rich? Because I mean, go in Best Buy and look for an AM radio. Good luck. You know,
I couldn't find one.
Go to their website and they do have a couple of the Insignia HD radios that you can get them to order them, but no, it's not something that's in the building.
I have one of those. It's a real turkey too. It doesn't hardly picks up anything.
What, the little one?
No, it's the one that looks like the Sanjin that came out originally.
Yeah.
But it
I
looks
love the
like one,
Sanjins.
but it's not. The Sanjins blow them away comparatively.
Yeah, I'm all Sanjin. Yeah.
There was a second generation Radio Shack bookshelf radio. It was about $125. And like I say, it was second generation. The chips wouldn't set fire to things. Power consumption was quite a bit lower than the power consumption was quite a bit lower than the very first ones. I have them here in the building, and they're the EAS stations. They pick up the Midland 1 and 2 stations. Because, you know, I think there's one digital in Midland and there are 2 digitals in Lubbock. One of them is mostly for multicast on translators. And I think Public Radio got a grant for a new transmitter, but I can't pick up any of those here. And I have a pretty good array of antennas, you know, scanning the skies.
Yeah, I have one of the Insignia Pocket radios, HD.
Yeah.
And it really stinks.
I bought one of the ones that it was like for joggers. You could have a little band. You'd strap it to your upper arm. And the thing is, I thought, you know, this thing should have a logo on it because it's eventually going to burn this thing in your arm.
I bought
but the
one
1,000
of those.
foot of wire dragging behind when you're jogging is what gets in the way.
Back in the early days of HD, I bought one of those at my local Best Buy store. I brought it back because it wouldn't pick up my FM station when I was standing next to it. It was deaf.
That's really weak. Cars. GM can't build cars. Nautel can't build transmitters because we can't get chips. So it's not like this is all going to happen real quick.
Well, that's another issue with the whole HD thing. Is only about half the cars that are sold today have HD in them, and actually with the chip shortage, I understand that even less are being delivered.
They may be shipping without. Yeah.
Yeah.
And a lot of the new cars don't have AM radio, period.
Right.
That's fun.
We have in Texas, they're talking about some state legislative action to get to incentivize chip manufacturing in the state, and I guess other states are looking at it also. What kind of does anyone have any idea what the first chips will be in these places? Are we going to make microprocessors? Are we going to make?
No, they're little diodes. They got 2 wires that come out of each.
It'll probably be something no one needs, you know, like we're going to bring back the 709
Maybe
IC.
Small radios, I think, are what they're going to call them.
Maybe Elon Musk will come up with something. He's already got a big plant down in Austin.
Well, they
Yeah,
have
but that's one of the cars that doesn't come with AM radio.
Yeah, I know.
There's a place up in Lubbock called XFab. They took it is a former Texas Instruments factory, and they do kind of small runs of custom ICs and stuff, have for years. They made the news earlier this summer because they had an explosion in a water height. What was they did? They not dialysis. What do you do to water when you break it up?
Electrolysis.
Electrolysis. Thank you. Yeah, they had some big electrolysis plant. And apparently, they built up enough hydrogen that little spark, and suddenly there's not a roof over one end of the building, and it did kill. It did kill a guy. Very sad. Wouldn't have thought of chip fabrication as all that dangerous of an occupation, but water apparently water cannot just drown you; it can blow you up real good.
They dope chips with all kinds of stuff you wouldn't want to be around.
That's
arsenic and things that are not good for you to breathe.
Yeah.
Yeah.
Talk about the dangers of dihydrogen monoxide.
Here's a question on our main topic from YouTube. Paul says, would it help the AM band if the FCC allowed AM translators to turn the AM off, but keep the translator on the air?
I think it would, actually. I think you'd find a whole bunch of small AM stations that would cheerfully get rid of their their AM transmitter, especially if there was an incentive to do it, like with the repack with TV, where these low power TV stations got money from the government to go away.
Would you do it for a tax certificate if you could just deduct the fair market value of the hardware?
I'd consider it. I seriously would, because I think most of my listeners are listening to FM translators. I know I have a few people. I got a call the other day from some guy saying, man, I really love your Tyler station on AM because that's how that music used to sound when I used to listen to it. And he's right. I mean, it was mixed originally. It's an oldie station, and the stuff was mixed for AM radio back in the late 60s, early 70s, until probably about 1980. Every recording studio had some kind of little Oratone speakers or something like that simulated what an AM radio sounded like, and they actually mixed to that. So
that was my first thought when I saw this translator thing coming down the line is, so this is what people are going to do, that now they have a get out of jail free card. They don't have to pay attention to the second and third adjacent or any of that stuff because they're translators now. So they can build FM stations where you never could build FM stations before, and then they just apply to go dark because they don't really want to run an AM station.
Yeah, but you have to take the translator off if you go dark, or you can. It depends on which filing window you got your translator.
Yeah, 24 hours after the AM goes off, the FM has to be off.
Yeah, but somebody has already applied to say, oh well, we've got all these FM translators. We'll just take the main off.
Oh, it's coming.
The FCC said no, but
I'll bet it's coming right along with some other stuff that we may or may not like too. But
well, you can just turn it on for a minute every 24 hours and you'd be legal.
Make sure you do that ID in your EAS and you're good. Maybe you could figure out how to remote control your transmitter so every time your EAS box goes off, it kicks the B+ on, and all of a sudden we now have AM.
I thought that 24-hour rule only applied to Class D AMs and not to Class A, B, or C's.
I think most of the translator permits say if the AM is not on, and it also usually says if you're on an STA that minimizes the AM coverage, the translator can't exceed the STA coverage either.
Yeah,
That's right.
correct.
Yeah, it started with the daytimers, the strict daytimers. They had to say, we'll let you operate it at night so long as the AM's coming on every day. But it seems like the last one of these I read included now it's 24 hours. The station needs to be there regularly.
They did that just so you wouldn't turn off your AM and just work on your FM.
I mean, margins are such and electricity costs are such that, gosh, it's a big win if you can turn off your AM. Even if you can turn off your AM for 90% of the time, you know, I don't know what it costs to run a big, you know, high power DA these days, but electricity costs aren't going down.
They're definitely not going down, and you know, I can see where people would go. I know quite a few stations. Couldn't be specific about them, but there are some AM stations that seem to have their AM off a lot and the translators on a lot. That seems to happen quite a bit.
Yeah, but that, I mean,
it's not right, but it's the way it is. Yeah.
Yeah, but we really need to get back to someday a set of rules that apply to everybody. And you know, if bad engineering is bad, it's not good under some circumstances. And so saying, well, you know, this station you can get away with this, and you know, it doesn't cause interference to the second and third adjacent if you're this class, but it does if you're that class running the same power.
What can you say? You know, I mean, you know, it either does or it doesn't, one or the other. And you know, what the class of your station should have nothing to do with the interference. But we have all these. I mean, if you go through the FCC rules and stuff, I mean, it changes all the time. They contradict themselves all the time. It's crazy.
Been fun. Got to go. You guys have a good, safe weekend and play nice now.
David, enjoyed your comments. Enjoyed having you with us.
So John, back on the topic, I have a question. I guess maybe not on the synchronous topic, but more on the digital radio topic. Are there any of the proposed or current digital radio schemes that actually use coding gain? I mean, it seems like your example of you're needing 30 milliwatts inside your house to hear a good, clean AM signal. Seems like we're trying to operate below the signal to noise ratio.
So you're referring to the signal to noise threshold of digital. Is that right, Bill?
Yeah, but you know, in satellites for the longest time, we've operated under zero signal noise ratio, just because we have you know, rate 1/2 FEC.
Right. Yeah, although that's isn't it usually a trade-off in data rate? And HD radio went through that decision process in its development, and it's a pretty optimal trade-off between I think between bit rate and required signal to noise ratio in the channel.
But we have a lot better digital audio codec schemes now too.
If you started over with a more efficient codec, you could lower the required bit rate, and you could then reduce the RF bandwidth, and that would improve the RF carrier to noise ratio. Yeah, that would all be optimal. And that's actually what DRM Plus does. It's somewhat more tolerant of RF noise in the channel because it's a narrower bandwidth. But HD radio was developed, you know, a couple of decades earlier.
MP3.
Yeah, its codec is not the most efficient by comparison with today's. And that's another plus for DRM plus and DRM. They can change the codec as codecs advance. They now use extended high efficiency HEAAC, which is about twice as efficient as the previous HEAAC. So that's how DRM on shortwave and medium wave are able to transmit, 3 or 4 multicast audio signals. They're using more efficient codecs these days.
Is that HEAAC?
Yeah, you might be familiar with AAC Plus, which was the successor to the AAC used for years by Apple iTunes. That one does not use spectral band replication. AAC Plus, also or officially known as high efficiency AC, uses spectral band replication, so that can operate with bit rates of 48 to 64 kilobits per second. Extended HEAAC can provide comparable audio quality at rates of about half that, like 24 kilobit stereo. And people will say, sounds just as good. So it's more efficient.
We need more abbreviations. And
oh, yeah. Well,
we could use the same ones over and over again.
Yeah.
Meaning different things.
These are usually the Europeans who are inventing these audio systems. They love acronyms.
So, John, when you were talking to Chairman Pai about this sort of system, I mean, did he sound interested enough to say, "Oh yeah, we could shut down the station in Sheldon and instead license a whole bunch of boosters along the I-5 corridor that covered a big chunk of population equal to what Sheldon was covering as a single station," or is that kind of too avant-garde?
It didn't go that far. It was confined to a discussion of, wouldn't it be nice to be able to do a rim shot? You've got a large community in the service area, but it's too far away to get a good signal. And a single frequency network booster on AM would allow you to serve that community. So it wasn't going as far as saying, how about getting rid of the primary transmitter and having distributed transmitters around the market? But I think that would be a good thing for some AM stations. It would be great to see somebody build one. But you could always start with the rim shot just to prove that it works. We just don't have a good working single frequency network AM at the moment.
Now, as a former Verizon lawyer, did he have any idea what you were talking about?
Yeah, kind of. Yeah, I mean, he was pleasantly enthusiastic, but obviously nothing came out of that discussion. So
I mean, I'm right with him. I mean, I loved when I was a high schooler, nothing more than sitting in my car at sunset in Los Angeles, listening to stations all over the country on AM. I mean, I'd love to go back to that. Ozzy and Harriet's off the air, and Amos and Andy, they won't let on the air anymore. So I mean, but I don't know how you take the chocolate out of the milk.
Well, this isn't a major overhaul for a station. If they had a more distant community they underserve with signal, single frequency network booster would be, I think, ideal, and it would work either for analog or for HD radio. Work great for either. Somebody just needs to have an application. It's like the station in Shelton, Washington. They said, boy, we'd really like to serve Olympia because it's the state capital, and our signal kind of sucks there, that would be a place to put in a 100-watt booster, and they'd bingo, overnight they'd have service. It shouldn't be a major cost.
One of my WOR radio network affiliates is in Olympia, KRKO. And the owner, I think, has 3 stations scattered around the Seattle area. And he wanted to do something. I've forgotten exactly what it was, but it was essentially running all 3 with the same programming. And I think the Navy got involved and accused him of interfering with some ships at sea. And I remember going to a ham radio club locally, where the attorney that represented him gave a speech. And I also had another affiliate in New Hampshire that had serious issues with tower height. He made some modifications and I think had to change either the height or add another tower. And, you know, the city got on his case. And this attorney handled both of those cases. Was interesting to see just how the whole NIMBY thing worked for them. And I don't think that Andy's Olympia stations were going to be on a single frequency, but all 3 would have the same programming. And both of them won. And I think one of the 2 sold his stations.
KRKO was in Everett, and he built in Snohomish and had a horrid zoning thing.
Right.
And they vandalized the station and knocked one of his towers down. He's had a lot up there.
Yeah.
Somebody needs to find a station that has this problem. I'm sure there are hundreds of stations that have poor signal in a little more distant community, and we're not going to do much to get rid of the noise sources. It's just everywhere, and I can't chase them down fast enough in my house. So if you can't beat them, well, then get more signal power locally in a community. I think an SFN would be a great project for a station. So maybe one of you know a station that could do it.
Well, actually, in my market, the noise is actually in the programming.
Oh, come on, not another Dr. Laura joke.
Yeah.
I'd like to invite Brian Henry, who's been watching and listening to us, and sure invite his thoughts on what we've been saying.
Yeah, Brian, you're the AM Improvement Working Group chair.
I think it's all been very interesting, and rather informative to try to just hear different people's thoughts on all of this. It's AM radio is a really, really difficult challenge. The AM improvement, first of all, I'd like to invite everybody who's on the call, if you'd like to participate in the NRSC's AM Improvement Working Group, you're very welcome to join into the conversation. It would be helpful, as we're trying to do a lot of things. And as you can see, just by the conversation today, it is a lot of different challenges that confront AM radio. I mean, we've been working on, John's been doing a ton of work. Obviously you can see some of it with the synchronization type stuff that we've been working on. And then we've also been, trying to look into this situation with noise. And also some of the discussion that took place with regard to receiver bandwidth, we've been looking into that as well. So, but we have not, I don't know, in some respects haven't made the kind of, oh wow kind of progress that I think we'd all like to see for AM radio. It's been truly challenging. I love the idea of the single frequency networks. And I was going to mention, there is actually sort of an active single frequency network working in the United States, and that's in Sausalito, California. It's actually kind of a Part 15 single frequency network that was done by Jonathan Westerling, and he has, I think, 600 or 700 milliwatt transmitters on the air, and by getting them all synchronized up, he's managed to cover the entire city of Sausalito, California, doing something like as what John is discussing.
Yeah, it's a distributed network.
And it works. It works extremely well. And, you know, it's unfortunate. I mean, as John says, there's a number of stations that could take advantage of this sort of technology. And it's, you know, unfortunate when I think that rulemaking proceeding was attempted, what is about 5 years ago, John, something like that. It was when the FCC, what they did was they took the stations in Puerto Rico and they took them off the air. And so then they filed a petition for rulemaking. And I think that essentially there were what, about 20 plus consulting engineers, individuals that made comments to the FCC like, do it. And there were no comments to not do it, and the thing got tabled. Why it got tabled is kind of beyond me, but it is a single frequency network is in fact one of the few things that could truly represent AM improvement, you know, and it stalled. And so, you know, what we've been doing in the AM improvement working group, we've kind of got two things that we're kind of been working on, and John was doing a lot of work. I wish he could spend some more time even talking about that today, where we're not only talking about doing like a single frequency network synchronization, but actually wide area synchronization, where like effectively many stations on a channel would sync up in terms of frequency. And one of the things that John recently did was he was establishing, I should have you explain it, John.
No, you're doing fine.
Right. Well, he was basically trying to establish on a given channel that, you know, the idea originally would be like, okay, we just sync every radio station in the United States on frequency using GPS. That seems simple enough, but there's probably no way to get the political will to do that. So what John decided was, hey, maybe we can figure out a way to synchronize just some of the stations on a channel, and maybe that would make a huge impact and a huge improvement. And I think to a certain degree, John has proven that, yes, that's true, that in many cases, you might only have to synchronize one or two stations on a channel to make a huge improvement for those stations in terms of, you know, audible beat notes during Skywave.
If only there was a regulatory body in the United States that was in charge of radio frequency licensing and regulation.
Brian, you touch on a very important point here that hasn't been discussed at that point, and that is not only do you have the stations on the carrier frequency, but you also have the output network. And different transmitter manufacturers have different output networks in terms of phase. And so even before you get started with the frequency coordination and the aural delay coordination, now you have that output network issue.
Yeah, you're right, Barry. Although we're talking about Skywave propagation here, right?
You're right.
So their phase is all over the place because you have varying reflection altitude from minute to minute. So it probably, it would be fine for ground wave. For Skywave, it's a toss up.
Yeah, and you're correct, Barry. The stations that were synced up in Puerto Rico, they all used the same transmitters. As I recall, they were the Gates series, the Harris Gates series AM transmitters. So that was how they dealt with that in Puerto Rico.
Right. But you have the development of low angle radiation suppressing Skywave is probably where you got to be.
Yeah, and I think the other interesting too, I should mention about the single frequency network thing. And, you know, we have technology today that we didn't have really even 20 years ago in terms of computer modeling, where maybe what you could do is use, as John was mentioning, inefficient antennas that aren't that big, that might just cover a small area. So you don't necessarily have to have 5/8 wave radiators or 1/4 wave radiators to do what he's talking about doing.
Yeah, some of these 125, 150 foot light poles, at major interchanges, you know how tall some of those are. Yeah, those are not the most efficient antenna, but you could load 500 watts into them with no trouble. And they're all standing around available. So yeah, generating power at AM these days is pretty cheap and easy.
And the other thing these programs do too now, which you couldn't do previously, is they can compute, skywave angles and things like that with, just a myriad of antennas. So it seems like there are things, and the other should go into one other thing too, since we're talking about AM improvement real quick, is that you have receiver capability that you didn't have 30 years ago when the NRSC was doing the work on AM improvement. So, it's like I just bought one of these little software dongles for $30, and it's better than just about every radio that, was built 30 years ago. So there are possibilities. I think the thing that is the most challenging, as I really see it, is political will. And I really believe that if this was like 1992, where you had a lot of independent AM broadcasters, it would be easier because they really, really wanted to do it then. And now it's harder because of the consolidation. I mean, that's my thoughts on that.
You can convince them one at a time instead of trying to convince their lawyer.
Yeah. Yeah.
I'm curious what kind of fence they'd require around those light poles.
Well, the highway information radios are like some incredibly loaded whip on a trailer with 2 wheels on most places around.
There's so many areas. I mean, I used to own an AM radio station in Northern California, and it's its predicted 2 millivolt contour was like 40 miles, but its actual 2 millivolt contour was like 10. That would be a great circumstance where this would really work. There's so many applications, and I don't necessarily think it would be that expensive to do it. But it's weird. The FCC, there have been moments over the past, and I'm sure John would confirm this, there have been moments over the past 100 years where they really thought, synchronous transmitters was a great idea. And then other times was like, they just completely would table it. And I think we've pretty much been in the tabled mode of late.
Yep, it's the concept preceded the technology to do it well. And for the last 10 years, we've had the technology, but we need someone, one of you guys or someone who's a station engineer or a group engineer who says, yeah, we've got a station that could benefit, and we'd build it. Shoot, I'd donate my time to help.
Well, I might have one for you, John.
Fine.
The FCC could sweeten the pot and say, if you trade in your big stick, we'll let you build lots of little sticks and keep the same population, or expand your population, or set up a set of algorithms to say, that encourages doing this, that, what. I mean, you got a 10,000 watt station, you're causing more interference for other possible stations in other locations than you're solving for yourself.
That's right. Your ground wave is a problem for your adjacent channel neighbor, for example. So yeah, if you could contain the coverage more efficiently with a distributed network, that reduces interference to your neighbor.
John, you just brought up the biggest problem of the whole idea. And don't get me wrong, I think it's a great idea. But like I live in New York, you're talking more real estate, and that is a problem on the whole thing.
Well, you can
low profile
load
antennas.
Sorry, what was that, Brian?
Low profile antennas, John.
Yeah, you can load into all kinds of structures and radiate. It's not as efficient as a quarter wave vertical monopole, of course, but it doesn't take a lot of space.
Yeah, but real estate is at a premium now. Come on, some people are giving up their stations just to sell the station for the real estate.
You can put it on top of a building.
Yeah, I'm saying you could find existing structures that could be loaded into by a low power AM transmitter and radiate. So you don't have to build land and build a tower.
You don't need 30 acres for your DA if you're gonna put up a loaded stick on top of an existing building.
Right, that's what I'm saying.
In Massachusetts, I think we still have one station that's synchronized. WLLH has stations in Lowell and Lawrence, and they're
somebody mentioned last week that was stopped.
It could be. I think the format has changed. It's now gone Spanish.
Dick Johnson was always complaining that one of them had dead air.
Okay.
At least twice a week he would complain and say they were just dead air for days on end.
Oh, okay. Well, they had towers on top of buildings.
Mm-hmm. Yeah, you don't need real estate. So I hope that'll satisfy David.
I was going to say there's one other thing too that was mentioned today, John, that nobody that could also make a really huge difference, and that is M3, the conductivity map. That I don't think has been revised since like the 1930s as well.
Yeah. And
so it's like there's a possibility for power increases without doing anything except revising that. If you think about it, I mean, I know like in Northern California, the conductivities are predicted to be like a 4 up there, and they're like closer to 0.5.
Ooh.
And that would instantaneously, well, guess what? You don't have to change the allocations or anything. Just change the, make the actual conductivity map represent something real.
We did a lot of that back in the 80s, ran around with field intensity meters and showed what the conductivity really was.
Every time you propose a change like that, the owners come out of the woodwork and say, "Oh no, you'll wreck my station."
And the NAB.
It's like they're struggling to keep the world in the 19th century.
Well, the NAB serves its masters well.